hello, everyone. Thank you for coming to this workshop where we're going to be showing and talking about how to build GenAI applications with the new GenAI stack that we put together. My name's Harrison Chase. I'm the CEO and co-founder of LangChain.
And I'm Michael Hunger, Head of Product Innovation at Neo4j. So you might have seen us this morning in the keynote. And what we want to do now is go a little bit deeper into the whys and hows, what's behind the scenes, what does the actual code look like, how you can get started, and so on. OK, so this whole GenAI Stack initiative has 4 partners. It's LangChain, Neo4j, all orchestrated by Docker and Ollama for the local LLMs as such. Just to give you some background, let's talk about LLMs and GenAI in general. Who has not yet used an LLM of you? One? OK, so you probably, or two, probably most of you have used ChatGPT in some form or another. So LLMs are a part of the new type of foundation models that are used to have been trained on a large amount of data to basically predict information. So traditionally, machine learning models were like in the realm of very smart data scientists who trained models for very specific purposes. So for instance, you had like a legal model to analyze legal text, or you had like an image recognition model to recognize certain parts or certain types of objects in an image, right? And this meant you always had to fine-tune or train models for very specific purposes, and you always had to put in a lot of specific effort by data scientists to make this happen. With foundation models, all this shifted because they basically say, OK, let's just train models on a massive amount of data and then use a prediction mechanism basically to say, OK, based on this data, it's kind of almost like world knowledge that these models learned. How can the inputs of the users, either as text or images or videos, be used to, for instance, generate information, detect things, extract information, and all the other things, right? And the really cool thing about this is that these models are now available to developers, right? You don't need to be a data scientist anymore. We'll talk a little bit about this later. And it all started in 2017 with the transformer architecture and from Google, which allowed us to kind of train these kinds of models. And the training volume has gone up quite a bit. So these large models have been now trained on trillions of tokens of information. And you have models from every kind of provider, right? From Google, from OpenAI, from Amazon, Anthropic, and many, many other. Meta, of course, with Llama 2. So there's a lot of models out there, right? And what's kind of interesting, from a certain training size, suddenly these models started to show emergent behavior, right? So you, up to a certain level, you kind of could expect what they would produce, but from a certain training size, there was like a threshold where suddenly it felt like more, right? So as if there was almost some level of understanding or some level of pseudo-human interactions possible, which is what we now see today in GPT-3 and 4, for instance. Right? And what's really interesting as well is these models now can hold conversations. They can keep previous context. They can work with larger context windows and things like that, which allows you to build much more natural working applications on top of them. Right? So why are they so hot right now? You can do a lot of stuff with LLMs. They are more like a general purpose tool, like a calculator or a computer in some way. Right? So it doesn't mean that an LLM will replace you, but it makes you faster, more productive, or smarter in some way as well, right? So you can automate a lot of data retrieval tasks with LLMs. You don't need to go and train a specific model to extract data information from things. You can improve the end user experiences both inside of your organization but also outside. So for instance, if you have databases, and in the past either people had to get apps written or write SQL or whatever query language themselves to access the data, now you can open this up to more people asking just natural language questions of your data, which is really, really nice. And of course, we are kind of all drowned by information. And so LLMs can help us, or foundation models can help us to make more sense or quicker summarize this information. Of course, there's a trap, right? So if on one side, LLMs are used to generate information, on the other side, it's kind of used to summarize information again, you could also just send the condensed version of the information. So there's also a lot of traps in the GenAI space. And especially for us as developers, code generation is really cool, right? So many of you might have used Copilot, but there are also many other tools like Duet. There's SQL generation from natural language, or for us, for Neo4j, Cypher generation from natural language. So there's a lot of stuff that we as developers can do better. Simon Willison had a really good article where he said, basically, it enables me to do things that usually would have taken 5 days and takes it down to 2 to 3 hours to build new things that I have not yet used before. There's some challenges with GenAI, right? So one is kind of the hallucination parroting, right? It just makes stuff up instead of saying, I don't know. The reinforcement learning with human feedback basically made these models more to, oh, I always have to please the human, right? So instead of rather saying, I don't know, they very convincingly generate, information, links, and other things, even if it's all fake. So that's a big problem because you don't want to put such a system into your application or into your enterprise, right? So you want to be able to trust these models. And then training data cutoff is a big problem, right? So because all these trained models go to a certain day. And what happens with all the information that was later, right? Or how do you access your own private information that sits in your own databases with these models? It's currently not possible. You have some plugins for accessing web and other things, but what happens with your databases as such, right? And then you have the whole security compliance, PIA, and so on. Right? So they're great at language understanding, and that's what we kind of use them for. So we basically just use their language skills, and we completely ignore all the training data that they have been used on. So hallucinations, again, very confident, making stuff up. It's sometimes like me talking about stuff, right? Like imposter syndrome type. I already mentioned most of these. There are also all the ethical aspects, right? Where did the data come from? Have people been compensated for instance, authors and artists for using their data for training? How do people or large companies label their data, right? So there's the whole labor and exploitation aspect. So there's a lot of stuff. There's also injection, right? Prompt injection is a big topic that's totally underserved. So there are lots of challenges that exist as such that need to be addressed kind of one by one by us. But in general, I think in the end, it will be more beneficial than negative. So I'm not on the negative side. So all these challenges with LLMs, how can we make it better? So there's some options. You can either take an existing model and fine-tune it, but it's a lot of effort, and oftentimes the outputs and results are not, at least today, not there yet where we want to take an existing model and fine-tune it. You can provide a few examples when you talk to the LLM, but then you basically have to hard-code these examples, which is kind of not really helpful. And then there's grounding or retrieval augmentation, which we'll go into, which is basically you provide the LLM with the information that it should use to answer the user's question, and you just use the language skills of summarization to get there. So, but there's really good opportunities for developers that.
Yeah, and so one of the most exciting things about this world that we live in now is that you don't have to be a data scientist to interact with these really powerful machine learning models. A lot of the main ones that people are using are just behind APIs. So OpenAI is behind an API, Anthropic's behind an API, and so you can interact with them super easily. And then there's also really exciting packages like Ollama, which we'll be using, which are locally hosted models, but they bundle it up super nicely. You no longer have to train the model, you just have to run it and serve it, and Ollama makes that really easy. So we're seeing this kind of democratization of who can use these large language models. There's some kind of like things, and there's work to be done as well. So it's not like it's a finished project. It's not like, there's nothing left to be done and we're all just going to sail off into the sunset. There's a lot of work that needs to be done to use these language models. So prompting is an entirely new kind of like discipline that's emerged. These language models generally take kind of like text as input and output text, and the output text is often either a response to a user or something that says how to do something downstream. And so it's really, really important to be able to kind of like best get the output text that you want, that yields the best result. And the way to do that is through prompting, where you kind of like carefully construct the string that you're going to pass in to the language model. There's other things besides the prompt that also affect the language model. So these models have things like temperature, which affect how kind of like random they respond. And so if you want like a really deterministic output, or pretty close to a deterministic output, you can set temperature really low. If you want a more creative and variable response, you set it really high. And there's no one that's right all the time. They're useful for different applications. So some of the creative chatbots that we see out there probably have pretty high temperature. Some of the more kind of like personal assistants that really want to do particular things really well have low temperature. And so there's a lot of techniques and triggers that developers can learn and become experts in order to best use these models. And then there's also all of the kind of like using the output of the language model, and that's kind of like where LangChain comes into play a little bit. But the idea is the output may be a text, but it often has more structure than just a text. And so you want to make sure that it's structured in the right way so that you can parse it and process it and maybe use it as input to an API or to run a SQL command or things like that. So there's a lot of work to be done in hooking up these language models to other sources of data and computation. And so I think, as we talked about before, there's a wide variety of foundation models which are available. You've got the major cloud providers all jumping in. You've got local models like Ollama, which anyone can run on their own computer. And then there's also AI native startups like OpenAI and Anthropic, which are kind of like at the base layer of a lot of the applications. One level up, you've got orchestration frameworks like LangChain, Llama Index, and Human Loop, which help orchestrate a lot of the language models and connecting them to other sources of data and computation. And we'll show more what that looks like in the RAG app. You've then got infrastructure, which kind of like encompasses all of this. There's deployment, monitoring, eval, tooling. A lot of this is similar to software engineering, but there's also some differences in LLM-specific tooling that's starting to come out. LangSmith, which we showed, is one example of that, but there's a lot others that some are really focused on kind of like monitoring the API responses. Some are more focused on the ML side of things, of helping you drill down into what people are actually using your chatbot for. And so there's a lot of new tooling emerging in this infrastructure category. And then the last thing that's proven really important, as Michael said, in order to get really good responses, you generally want to have some sort of database that you're connected to and is powering the actual facts of the application. And so there's so vector search and vector databases have emerged as this new form that's proven really powerful to connect to language models. But there's also all the existing databases like SQL and graph databases, which you can still use to provide this context. So looking at this in a little bit of a more broken down picture, you can see here that, so this is from A16Z. It's from a few months ago, so that's why it says partial next to it, because the space changes really, really fast. And you can see that there's this orchestration layer right in the middle, and that's kind of where LangChain sits. But then there's all these other pieces that are all around it. You've got Playground, you've got APIs and plugins. At the top level, you have kind of like the contextual data, so data pipelines, embedding models, vector databases, and if we were to extend that today, we'd also put like other databases like graph databases and SQL there. Then you've got all the kind of like infrastructure in the bottom with the LLM cache, logging, LLM ops, validation. You can even zoom into that more. And then you finally get to the app hosting. So a lot of what we're showing today looks like a pretty simple app at the surface, but we'll show the code and we'll show a lot of these different components behind the scenes. And part of the value prop of the GenAI stack is to simplify this a bit and give you a really easy way to get started with it. So I've talked about LangChain a little bit so far. And so just to dive into that a little bit more, LangChain is a GenAI orchestration framework, so it connects to all these different modules that you see up here. So tools, example selectors, prompts, vector stores, document loaders, output parsers, text splitters, models, probably other ones as well that we're not mentioning here. All of these are different modules in LangChain, and applications generally consist of 4, 5, 6 different of those modules constructed in various ways. And so we provide kind of like a standard interface for all those modules. So we have a standard interface for, I think, over 50 different LLM providers. And then we also have implementation of some of those modules that we do ourselves. So text splitters, for example, are one implementation that we have that's in LangChain that's kind of like native to LangChain. The other value prop of LangChain are pre-built chains and agents. So as I said, a lot of these applications are these modules, or like 4 or 5 of these modules constructed in particular ways. And so we have a lot of off-the-shelf chains and agents that are basically pre-built templates to accomplish a variety of tasks. And so we'll be using one of them today to do the retrieval QA with sources chain, and we can dive into what exactly is going on behind the scenes there. I'm going to hand it back to Michael to talk more about RAG.
So RAG is all the rage today. All right, so as I mentioned, the backing or feeding information from databases or data sources to language model to help users is kind of currently the best way of approaching the hallucination and knowledge cutoff thing. And RAG is an acronym that stands for Retrieval Augmented Generation. And that's basically the idea. There was a paper, I don't know, 2 years ago or a year ago or something like that, or even not 6 months ago probably, where they kind of explored this, and this really stuck because people saw the value of it. And it basically, you ignore the LLM training data, you just use the language skills. You take the user question, you turn the user question either into a vector embedding or into a database query, send it to your database or data source, extract the relevant information for this question, not all the information in your database, because that's too much, of course, right? But the relevant information for this question, and then you send the question with this information to the LLM to produce the answer for the person, right? So that's kind of the approach that you also see here in this pattern. Sometimes you can even decide, actually, do I need to get to the database to get some information? Like, for instance, if you just want to ask, or if you just have a creative task, like, generate me some ideas for my next project or something like that. So for creative tasks, you can also go directly to the LLM. But for everything where you actually want to access your internal data, then you would go to the database and do this. So the GenAI stack, as we showed this morning as well in the keynote, there are not just the components that we talked about, but also a number of example applications already part of the stack. We're going to add more to it, and we also, of course, are interested in your feedback. So if you have ideas or questions, feel free to open GitHub issues or send pull requests to the repository as well. So the first app that we have in there is the knowledge graph import that basically fetches data from an API, creates the data in the database, generates the embeddings, stores the embeddings in the vector index, and so makes it available for the other apps to use that. The second one that we showed this morning was the chatbot that allows you to either do directly LLM interactions or use RAG with the database. We also have a function in that app that says, hey, if we didn't have the information in our knowledge base to answer this question, then can you pick basically the top or the best rated answers the best rated questions in our knowledge base to generate a new ticket for our internal support team to answer this question. So it would take all the input from the user question, plus the tone and style and type of the best rated or highest rated questions in our knowledge base, and then generates a new question in the same tone and style as such. And then the fourth app that we have in there is basically chat to your PDF. You upload a PDF, it's turned into chunks, into vectors, and then you can use LangChain and the UI and Streamlit to chat to the PDF or ask it questions about this PDF, which is also a common example of how you make documents accessible that are not databases as such. And again, building blocks for the GenAI stack, as we mentioned several times already. And it's all pulled together by Docker Compose. So there are brand new base images for Ollama, especially also on Linux, working out of the box. LangChain-based image is both are official images as well, and then the Neo4j official image, which has been around for quite some time, are all pulled together by a Docker Compose setup, which basically orchestrates and configures all the environment variables to which model to use, what is the LangSmith connection information, for instance, or what kind of internal, external information do I also want to pull in, right? So if you look at this, the flow in the app, this is kind of what we've talked about in the containers, right? So you would basically in the bot, you take in the user question in the Streamlit app. So we're using Streamlit as a UI framework today because for Python developers, that's the best way or the quickest way to get to prototypical UIs. So you don't have to have an API and then JavaScript frontend, but you can basically just use directly Python to run your application. So you take the user question, you go to the embedding model to generate a vector embedding for the user question. For instance, you can use sentence transformers, but also Llama 2 or others, OpenAI, for instance. You get the embedding, you go to the data vector search in the database, you do the vector search, and then because it's a graph database, you take whatever were the top K elements from the vector search and expand the context. So what else is related to this question, right? What are the top rated answers? Which other questions are related to this through tags and other things as well? And then you take this information and send it to the chat model, which is a different model than the embedding model, through LangChain and get the answer back, which you then render in the app as such. And let's go into that and show the demo. I'll start and then Harrison will look at the second part. So as we showed you this morning, you can basically run, so I can run this again here, Docker Compose up. You can also look into the Compose file while it's doing things here. So the Compose file has a bunch of components in here. So we have the LLM image for the local Ollama managing the local LLMs. We have a pull model image which pulls basically the image from the Ollama registry. So you, depending on which model you want to use, you would pull this model. These models can be pretty big. So the small models like Llama 2, 7 billion is 4 gigabytes. The 13 billion one is 13 gigabytes. And the 70 billion one is 30 gigabytes or something like that. So it's a lot of data. But Ollama also holds this locally, so you don't have to reload it. So if you run it, pulled it once, then it's on your machine and you can run this. Then database Neo4j with health check here. And then we have our different apps. So we have the loader, we have the bot, we have the PDF bot, and that's basically our images that exposing different ports on this machine, and the configuration then passes in either information for local images, or you can also put in your OpenAI key, and then you can use GPT-3 or GPT-4 as models as well. And so meanwhile, our Docker Compose down was successful. And if I start this, it basically pulls up the LLM model, the database, and the apps as well. And while it's doing this, I can show you in the UI, basically we have our loader here that should be running right now. Let's see. So which basically means you can pick any Stack Overflow tag that you're interested in. So for instance, imagine we want to add Docker questions to our database. It fetches the last n pages of questions, all the questions, all the answers, all the users, all the tags, and embeds this into the vector embeddings, and then fetches that. So this should take roughly 10 to 20 seconds to fetch 100 questions, the last 100 questions on Stack Overflow about Docker. So if you're asked to answer the question in the last few days, then your question will probably be in here. And it adds it to the graph database. So you see the import is now successful. You can jump here directly with the link to the database. And here you see this, the data model with questions, answers, users, and tags. And if you go to the database, then we can explore this data, navigate through it. So you see in purple the questions, the blue ones are the answers, orange the tags, and then I can say I want to expand, for instance, this tag, and then I see all these other questions as well in here, right? And you can create this database and so on, and all of them also have like vector embeddings. So when I basically look at one of these questions, then you see here I have the question body, and here you have the embedding data directly attached to your entity, which is then also stored in the vector index for the search as such, right? And so that's the database as such, and how you can populate it. And it uses basically just a Stack Overflow API call to fetch the data from Stack Overflow. But you can imagine this data can come from anywhere, from any API, from any data source, you name it, right? And then the bot is in the first mode, when RAG is disabled, it talks to the LLM, whichever LLM you have basically used directly, and then you can say, for instance, how do I use Docker Scout or something like that, right? And then it shows you the information, and it basically gives you something, but I don't know yet. This should actually be, I think that's Llama 2. It might actually already have information about this, but let's see. If we use the question that we had today, this morning, how do I summarize PDFs using LangChain? Then it says basically, I don't know about anything about LangChain, right? So because the knowledge cutoff was before LangChain was released last November, right?
Yeah, it thinks it's blockchain. So
oh yeah, it also thinks it's blockchain.
By the name.
So it's a really smart choice of name, Harrison. And then you can basically compare this with the same question going to the RAG store. So which basically exactly does what I explained before. It takes your question, turns it into a vector, goes to the vector index, searches the top K documents or elements in the graph database, and then goes from these questions to what are the most highly rated or accepted answers, and passes those questions plus these answers to the LLM to answer our question here, right? So there's a lot of stuff happening behind the scenes. We look into the code as well. And so this is actually taken from the Stack Overflow articles that are in the database. And one really nice aspect of the RAG pattern is also that you get basically referenceable and verifiable sources back from your answers, right? So it's not just it generates an answer, but if you pass into the LLM also links or URLs or other kinds of sources that your text chunks or your information is basically verified by, then you can tell the LLM in the prompt to use that to basically regenerate these source links when it outputs or summarizes the answer. So you can then use those to go into the detail, right? So then I can just click on one of these links and get my information here, right? And the last application is, as I mentioned, is an PDF chat bot. We can here take Einstein's invention. While I'm looking at, there's also what's this? If I want to, if I'm not happy with the answer from the LLM, then I can also say, generate a draft ticket for me. That's the other app that I mentioned before, which basically takes the top-rated information from the database or the top-rated questions from the database and generates an answer in the style of that question as well. And here we basically uploaded Einstein's pattern inventions and can say list all inventions in the file or in the by Einstein. So, and then it basically takes these text chunks again that were extracted out of the PDF and summarizes it, fetches the most relevant information, and then returns the answer for that. Right. So that's kind of the outside. So all these apps are Streamlit apps. We're going to add also more LangChain.js apps and apps that have APIs and have a JavaScript frontend as well. So this is only like the starting point. And here you see basically from the PDF things like that, and including that Einstein designed a blouse that was a practical invention rather than a scientific one, which is also in the PDF as well. Right? So if you want to look into the code for all of these, it's probably also something that Harrison can talk about a little bit more. You have basically functions that, for instance, only use the LLM, which is this one, that have a prompt that says you're an helpful assistant to answer these questions, and then uses prompt templates to fill in the human questions as such and the system message question, and then it uses a streaming output. You see that it like ChatGPT, it generates the answer as a stream. So that's why you have this callback here that you use, and then it basically invokes the chain with the user input and the callbacks, and then starts generating the answers. So that's basically all the code that you need to do an LLM-only chat. And then if you want to do the RAG one, then we have a more involved piece of code. Here, the prompts are a little bit more involved. We kind of explain what you're seeing and that you have sources in there and links in there. Here in this section will be the summaries from the database query. And then the user question gets passed into the user template as such, right? So it also says each answer should also have a link as well. And we also say if you don't know, then don't try to answer, just say that you don't know. And sometimes, yeah, exactly. So, and then this is taken into system and human templates, chat prompt, and then we see here the vector and knowledge graph integration, where we basically just say in the LangChain vector store package or part. We can pull in the Neo4j vector store. We can also pull in other vector stores if you want to. And you say basically, this is my vector index. This is the field to look for. And then you can actually provide this graph query, which then goes to the question and fetches related information to pass back to the LLM. And then you combine this all with an retrieval QA chain to combine the QA chain that you configured with the vector store as retriever. I want to have the top 2 elements. You can increase this, but then the amount of text that gets passed to the element gets bigger, and there are some effects of that. So one is that it becomes more probabilistic because it starts, for instance, to ignore stuff in the middle of the prompt and things like that. So 2 to 5, depending on the volume of text that you have in your chunks, is usually good. And then this is our QA chain that we then use to answer the question. So that's kind of the code behind the scenes. And Harrison will look a little bit into how can we figure out what's actually happening while this code is running.
Yeah, absolutely. So the last thing that Michael showed was this retrieval QA with sources chain, which is a class in LangChain which contains a lot of logic for doing this exact RAG-based application. And so that's great because it means it's easy to get started with just that class. But that's a little bit unideal because that class actually contains a decent amount of logic in it. And that's one of the actually simpler classes in LangChain as well. So some of the more complex ones have even more logic inside them. And so as you're building your application, it's great to get started with a few lines of code, but it's really important to understand what's going on under the hood so that you can debug it and improve it and really bring it from a prototype to production. And so in order to help with that, we've created LangSmith, which is a debugger. It does a lot of things, but the main thing that people use it for is this debugging and observability to see exactly what's going on under the hood. And so if we look at, we can see here there's actually 3 different types of sequences. So this is the first one. This is just the first LLM call without any RAG things. And this is just a really simple prompt and LLM, so it's pretty straightforward. Just to use this as an example of showing off some of the cool things that LangSmith enables as well, though, you can see exactly what the inputs and outputs to each step are. You can see any metadata associated with it. And then when you go into the LLM place in particular, you can actually open up a little playground and then mess around with it. So you can see the settings over there. You can change the inputs and then rerun it and get an output and basically debug it kind of like live. And this is really helpful when you have a sequence of multiple LLM calls. If you want to try to debug the third one in that sequence, you need to recreate the exact state that it was in, the exact input variables, the exact prompt template. And so rather than trying to do all of that, independent in your app, you can kind of just easily open up the playground here. Going back to here, we see that there's 2 more types of chains. And these are actually very similar chains, but with just different prompts. And so if we look at this one, the retrieval QA with sources chain, we can see that the sequence of steps, there's first this retriever step, and then there's this stuff documents chain. And so if we look at the retriever step, we can see that what this is doing is taking in a query and returning a list of documents. And so here we can inspect like what exactly are the documents that we're getting back. And we can see them all in here. The stuff documents chain basically takes these inputs. So it's got a question, it's got the chat history, and now it has this input documents. And these are coming from the previous retriever step. And then under the hood, what it's doing is it's passing all of those into a final call to the language model. And so if we open this up into Playground again, we can now see the system prompt, which was what Michael was pointing out earlier. Use the following pieces of context to answer the question at the end. The context contains questions, blah, 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 blah. We get down here, and we now see the content. And it's pasted in here. And then all the way at the end, we see the user question. How do I summarize PDFs using LangChain? And so we can see exactly what this prompt looks like by the time the retrieval step has been done. If we go back to here, we can see that this chain looks basically the same. And so what's going on is the main difference is the prompt that's being passed in. And this is why the prompts were so important earlier, is because they tell the language model how to perform. And so if you remember the difference between this result, where we get the references, and this result, where we don't, the only difference is the prompts. So one prompt's telling it to generate a list of sources and cite its answers. The other one's not asking for it. And so that shows a lot of the flexibility that you can have with this type of prompting strategy. I believe that's it for what I wanted to show in here. And so I think we'll go back to slides for now. And so I think the next few slides are all walking through the details of this application. And I believe we'll share these so that you can see in more detail. But we're using Docker Compose for a lot of the orchestration. We've got the various containers that are all getting pulled up. Ollama, they're upstairs in the booth. They're great. You should absolutely go check them out. We're using their local LLM. These are the other LLMs that we could sub in should we want to, and all of these have kind of like integrations with LangChains with the same exact interface. So it's very easy to swap them in and out and experiment. I believe there was someone during the keynote who was talking about like the importance of basically this rapid experimentation phase to figure out what you or your company is going to build for GenAI and actually have product market fit with that. And so that's part of the value prop of LangChain as well, as this rapid experimentation. Neo4j obviously as the knowledge graph here. And I think like one really interesting thing, one like big benefit of Neo4j in my mind is that visualization of all the different concepts that you've got going on. I think a lot of these applications, again, connecting it to your data, a lot of it's throwing the data into a vector store. It's really, really nice to be able to visualize what exactly is in your vector store, the same way that it's really nice to be able to visualize what's going on in the chain. And I think like one maybe theme of all these LLM applications is that as you add this like stochastic nature into it, observability becomes really, really important. And so I think that's a big bonus of this GenAI stack that we've put together, which helps. And so the Neo4j stuff is used to ground LLMs in the knowledge graph. We can see that there is this import step. The indexing step is really, really complicated as well. We could, that's probably a separate talk by itself. There's a lot of different options that go on behind the scenes in terms of how do you pre-process this text, split it into chunks, put it exactly into the vector databases with the different tags, so that you can get this nice visualization right here. The LangChain part, again, kind of like these different components, the ways of constructing the app. And then a few of the applications that were created. First was this support agent bot, which answers based on the question. You've got it's written in Python, the UI is in Streamlit, and it's got, it uses the LangChain prompts, embeddings, LLM, and then Neo4j under the scene. And specifically, you've got this like user question that comes in, a QA chain that configures the prompts to provide an output, and then also list out the sources, and then it renders it in the UI. Some more details here on what specifically is going on with the Neo4j vector store. So you embed the question as a vector, you pass it in, you find relevant documents to that vector, and then pass it back. This is the workflow that Michael showed off as well, where you're generating a ticket. So there's no answer in the knowledge base. What do? You turn the user question into a ticket. And this is a really interesting point because I think one of the big things that people are still trying to figure out, and why it's a really good time to be a developer right now, is like, what is the right UX for all these GenAI applications? Because they can be really good and they can be really powerful, but they're not perfect. And so how do you kind of like both communicate that, but then also make up for that with kind of like things that go into the UX? And this is a bit like, application specific, which again is why it's a great time to be building applications in GenAI right now. This is a screenshot from the LangChain documentation that just shows off some of the use cases that we have. So if any of these spark your fancy, I'd be sure to go check them out. There's a lot of different use cases, and there's also a lot of different integrations, and so those are on the other side. And so you can see that we have a lot with all the main kind of like cloud providers, but then all those different components, there's 50 to 100 under each of those for the different types of tools, retrievers, LLMs that you can pull in. LangSmith, as we showed, is kind of like the observability step for your LLM applications. What are the sequence of steps? What are the inputs and outputs of each step? Right now, it's in a private beta, but we've made a code for everyone here today. So we'd love for you guys to try it out, and that QR code should open you up to LangSmith right there. And if you missed this, come see me afterwards, and happy to get you set up. And that enables views like this, where you can kind of see the exact trace and the exact inputs. And so I think Michael's going to talk a little bit now about how you can access all this stuff that we've been talking about.
Yeah. Thank you, Hassan. So where can you get it? So first, the easiest way to get it is just open your Docker desktop in the Learning Center, and in the middle you should see under AI and ML guides the GenAI stack. You click on a link, and it gets you basically to the Git repository that you can clone and basically get it, download it, run Docker Compose up, and you should be up and running. If you want to add other things like, for instance, OpenAI APIs, then there's an .env file that you can configure with your OpenAI key, or if you want to run and use a cloud-hosted Neo4j database, or if you want to change the types of models that it uses, it's all in the configuration. And stay tuned, there's more to come there as such. So please feel free to give us feedback. There's also the Docker AI ML hackathon going on. So if you want to try out the GenAI stack, this is a really good opportunity. So Docker has a lot of great prizes for the hackathon. It's going on for 5 weeks. So you have plenty of time to get familiar with this, get started, and that's great. Our own developer conference is going on the 26th of October. So if you want to learn more about this graph way of seeing things and connecting information, come by. We have 24 hours of content around all time zones with more than 100 talks. And ML and AI is a big aspect of that, including also powerful visualizations and so on. And otherwise, thank you. Neo4j and Olama have booths on the second floor. If you want to drill deeper or go more into the code and talk to us about some of these things, feel free. Otherwise, you can also find Harrison or me or any of the other folks that were here this morning to answer your questions as such. Thank you so much. We can also do questions right now, but I don't know if you have a microphone or something. Otherwise, you have to probably yell at us. So feel free to. Yes. So a graph database is, first of all, a general-purpose transactional database that stores information as entity and relationships. So unlike a relation database where you just have tables, you have really like entities as one type of object and relationships as another one. And a vector database or a vector index in more general is an it's an index that takes multidimensional floating point encodings of the essence of information, right? And vector encoding on vector embedding is more like what's the essence of the sentence, or what's the essence of this picture, or what's the essence of this word or video or something like that, into a multidimensional vector space. And these vector indexes or vector databases basically allow you to find, for a given vector, like you use a question, what are the most similar or most close other vectors in my database that already exist, either by distance or by angular distance, so it's cosine or Euclidean distance. And vector databases are basically just very fast algorithms that take large volumes of these vectors that pre-exist and find the closest ones to your input. And there are many vector databases out there, like for instance Pinecone, VV8, and so on. But many of the other databases like Neo4j, Mongo, Postgres, and others have added actually vector indexes to their regular databases. So you get the benefit of having a regular database with all the benefits that you have today, like security, live updates, and all the other things, together with the vector search. Right? So if you have a very narrow use case that you just want to do vector search and nothing else, then a vector database is good. But if you have already existing data in your database, then you can use the vector search capabilities of your database as such. Yes?
So I have a question for Jay. So as you said, like prompts are like probably the most important thing when interacting with these LLMs. So I read about this concept of asking AI to generate prompts as well.
Yeah.
So in that chain, do you have any like tool or something like that which basically assists you in like creating those prompts or suggests you like how you can query the LLM better?
Yeah. There's been a few kind of like research papers in that vein of taking kind of like a prompt, asking the LLM to improve it. I think we have implementations of one. There's one called Ape Automatic Prompt Engineer that does that. I'm actually a little bit bearish on that use case because I think a lot of the times when LLMs get things wrong, it's not that there's like extra space where there shouldn't be a space or things like you look at some of like the mid-journey prompts, right? And they have these like random characters, right? And there's a lot of like kind of like artwork that goes into like figuring out what sequence of words to put next to each other. I don't think LLMs are quite like that. And I think a lot of the times when they mess up, the real thing lies that they're just lacking the correct context to answer. Like they don't have the data that they need to be grounded in. The instructions just aren't clear. And so if the instructions aren't clear, it doesn't matter a little bit there. One thing that I am more bullish on, excuse me, is maybe the idea of using an LLM to suggest ways that a human, like more information that a human could bring to the prompt, not necessarily doing it itself, because I think it's hard for an LLM to automatically bring some of that information in, but saying what things like aren't clear. And I'm a bit more bullish on that.
Cool. If you have more questions, just find us afterwards. We need to make room for the next presenter. So just come around and we'll be here. Thank you all.
Thank you, guys.
Thanks for attending. See you around.